start on graphing cotangent. I reminded us of the unit circle definition, which is that it's capital X over Y, and I've marked off my quadrantal angles. I can see I'm going to have problems now at these 2 points, because that's where the capital Y value is 0. So that's where my vertical asymptotes will be, and that's at multiples of pi. So just going from 0 to 2 pi, I've got a vertical asymptote along the y-axis, one at pi and one at 2 pi. At my other quadrantal angles, pi over 2 and 3 pi over 2, I'm just going to get 0, because then the x value is 0, and 0 on the top of the fraction, and the bottom isn't 0, makes the fraction 0. So just like with tangent, we alternate asymptote 0, asymptote 0. It's just that the asymptotes are at different places. They're at the multiples of pi. Same place, by the way, that they are for cosecant, because cosecant is the other function that has a capital Y in its denominator. All right, so in trying to figure out what this looks like, if I just do the rough sketch, I can say this divides things up into intervals that correspond to quadrants. Quadrants 1, 2, 3, and 4, just like we did last time. Well, in quadrant 1, every trig function is positive. So, drawing it backwards, I'm going up towards infinity. Of course, reading the graph left to right, we're going down. In quadrant 2, cotangent would be negative, so we'll go down towards negative infinity. In quadrant 3, cotangent is positive, and in quadrant 4, cotangent is negative. So the asymptotes are different places, and instead of going up in between asymptotes, we go down in between. We go down in between asymptotes. Okay, so it looks like, again, the period is going to be pi. Okay. Because in one revolution, it repeats the same pattern twice. So tangent and cotangent, the period is pi. They do their thing twice in one revolution around the unit circle. All the other four, sine, cosine, secant, and cosecant, the period is 2 pi, corresponding to a full revolution. Okay, as with tangent, this is very rough. Sometimes that's good enough, but if I'm actually testing you on graphing, I want things a little bit more precise. So I would say the increment, again, is pi over 4, and I would mark off some additional points so that I get the steepness with a little greater accuracy. Okay. So I'm going to mark off pi over 4, and then 3 pi over 4. Here I'd have 5 pi over 4, and 7 pi over 4. Okay. And the values I'm going to be getting are going to just be 1 and negative 1. Cotangent of pi over 4 is positive 1. For the angles where pi over 4 is a reference angle, but we're in a quadrant where it's negative, we're going to be getting negative 1. So that just allows me to get the steepness with a little bit greater accuracy. So this right here would be 2 full periods with 3 points per period labeled. Sometimes I might, depending on how long a quiz or an exam is, I might say draw exactly 2 periods, in one of them label the 3 important points, so that I'd only require the labeling here, but I'd want to see the second period. Just make sure you read the directions to see what I'm looking for. Okay, for the domain, again, that's going to be everything except where the asymptotes are. That's going to be everything except angles whose terminal ray passes through one of these points. That's going to be everything except a multiple of pi. So it's a set of all x such that x is not n times pi, where n is an integer. Okay, and the range, very similar to tangent, we're hitting all the y values. So the range is going to be everything from negative infinity to infinity.